Welcome to AI Frankly, the only podcast executive produced by an AI. We use AI to talk about AI. That's the whole point.
Today we're talking about something most people get wrong when they use AI tools at work. They think deleting their name from a document makes it safe to upload. It doesn't. We're going to show you why and give you a framework called the clean room method to fix it.
I have to admit, when we first started digging into this, my immediate thought was, aren't we just making things harder for ourselves?
Exactly. My first reaction was, wait a minute. The whole promise of these tools is speed. It's about efficiency.
It's about taking your mess and getting a clean answer.
Yes. You drop a messy file into this magic box, and poof, you get a beautiful summary. So if we're now saying you have to add all these extra steps, all these security protocols, all this manual scrubbing,
Are we defeating the purpose?
we're defeating the entire purpose of the tool in the first place. It just feels like we're going backwards.
And that is the perfect place to start, because that friction is what gets people into trouble. Let's paint a picture. It's a bit of a generic story, but I promise you almost everyone listening has felt some version of this.
Okay, I'm ready. Set this three for me.
All right. Imagine a user, let's call them the researcher. They've been working for weeks, maybe months, pulling together intelligence for a big project.
Okay.
And they have this huge, sprawling folder of notes. I'm talking transcripts from confidential interviews, raw data dumps from a client's private server, maybe some really sensitive emails about a potential merger. It is a complete mess.
The classic digital shoebox full of secrets.
That's it exactly. And they do what everyone does now. They grab that folder, they drag it, and they drop it right into a tool like NotebookLM, or maybe a new chat in Claude or ChatGPT.
The standard operating procedure in 2026.
And they type in a simple prompt, something like, summarize the key risks and opportunities from these documents for a public-facing blog post.
Okay, that is literally the use case these companies put in their TV commercials.
Yeah.
This is what it's for.
The tool spins for a few seconds, and then it spits out this beautifully structured summary. It's got headings, bullet points, it's 90% done. The researcher's thrilled. They're thinking, this just saved me 8 hours of work.
But there's a but coming.
There's a big but. They scroll down to the third paragraph to double-check a detail.
And what do they see?
Just casually inserted into the middle of a sentence, right there in the generated text, is the researcher's full name.
What?
Then it mentions their very specific internal-only job title. And then, for good measure, it drops the name of a confidential client who is under a strict NDA.
Wow. That is the moment where your blood runs cold.
It's the stomach drop moment.
Yeah.
Because if that output had been a newsletter or a podcast script that went live, you just doxed yourself, you violated an NDA, and you probably just got yourself fired.
And here's the most important part of that story, I think. This isn't a glitch.
Not at all.
It's not a bug. The user didn't ask the AI, please leak my client's confidential information. They just asked for a summary. But because that sensitive data was in the source documents, the AI treated it as fair game.
It treated it as a helpful fact to include.
Okay, but hang on. This is where I, and I think most people, would get stuck on the why. Because if I'm that researcher, my very next action is obvious. I go right back into that chat box and I type in all capital letters,
Do not mention my name.
do not mention the client, forget you ever saw it.
And that is the trap. That is the fundamental misunderstanding that this whole deep dive is about.
How is that a trap? It's a direct, unambiguous instruction. These models are supposed to be geniuses. They can, write sonnets and debug code, but they can't follow a simple negative constraint. It doesn't make sense.
It doesn't make sense to us because we think like humans. We have to look at the hierarchy of AI attention. We have to get under the hood of why the model ignores your all caps screaming.
Okay, let's do it. Let's get technical.
You have to understand the fundamental difference between the prompt and the source.
Okay, prompt is what I type. Source is the file I upload.
Correct. And when you're using any of these modern tools, especially ones with RAG, that's Retrieval Augmented Generation, which is basically any tool where you can upload a file, the model is doing two things. It reads your prompt, please summarize this, but don't use my name. Yeah. And then it retrieves chunks of text from your uploaded file to actually answer your question.
It's reading the book I gave it to write the book report.
Precisely. But here's the critical distinction. To the model, the source content is treated as ground truth. It is the state of the world. It's the factual reality it is operating inside.
It's the map.
It's the map. And your prompt is just a request. It's like a suggestion for how to navigate that map.
So if the map says this city is called John Smithville, and I say in the prompt, please give me directions, but don't mention the name of the city.
The model is in a bind. The fact on the map has this enormous gravitational pull. The fact is, confidential report by Jane Doe. That token sequence, Jane Doe, is now in the active context window. The model sees it.
So it's a conflict of interest right there in the neural network.
It's a direct conflict, and these models are optimized to be helpful and comprehensive. So when it sees Jane Doe as the author in the source, its internal logic says, well, to give a complete and accurate summary, I should probably mention who wrote this. The instruction, don't use names, is actively fighting against the massive factual weight of the name being right there.
So the prompt competes with the source.
And the source almost always wins, especially over time. You might give that instruction at the beginning of a chat, but 20 prompts later, after you've asked 5 follow-up questions, that initial instruction starts to fade. It's called context rot or attention decay.
But the source document is still there.
The source document is always there, staring the model right in the face, which leads to the big, uncomfortable conclusion.
You can't fix this with better prompting.
You cannot. You cannot prompt engineer your way out of a data leak. If the sensitive data is in the room, it can, and probably will, leave the room.
Which brings us to the framework you mentioned at the top, the clean room method.
Yes, the clean room method. And it's important to stress, this is not a piece of software you buy. It's a workflow. It's a mental model and a set of operating procedures you follow.
Okay, what's the core rule?
The core rule is simple, but it's rigid. Never generate public-facing AI content from the same documents you use for your private research.
Okay, I'm just going to say it. That sounds incredibly inconvenient.
It is inconvenient. So Jijinwa is wearing a seatbelt, so is putting on a hazmat suit before you enter a nuclear reactor. We do it because the alternative is a catastrophe.
Fair point. So it's about hygiene. It's about sanitation, not just editing.
Exactly. Sanitation is the perfect word.
All right, walk me through it. How do we build this digital hazmat suit? What are the steps?
It's a 5-step process, and step 1 is the most important conceptually. It's the separation of church and state.
Which means that
You need 2 completely separate environments. And I don't just mean 2 browser tabs. I mean 2 different mental spaces, and ideally 2 completely different fresh chat sessions.
And what do we call these environments?
We call them the dirty room and the clean room.
I like that. It's very evocative. It feels a little bit like a crime scene procedural.
It kind of is. You have to treat your raw data like it's radioactive. The dirty room is where you do your initial research. That's your first chat session. You dump everything in there. The raw notes, the internal acronyms, the client names, the messy transcripts, the spreadsheets full of numbers.
You let it all hang out.
You let it all hang out. And that's fine. You use the AI in the dirty room to explore, to synthesize, to understand. You ask it questions for your eyes only. What are the top 3 themes in these interviews? Explain this complex financial term to me like I'm 5. What is the overall sentiment here?
So you're using the AI to learn.
To do your homework.
Exactly. But you never, ever hit copy and paste on an answer from the dirty room and put it in a public document.
Because that room is contaminated. It's toxic. It is radioactive. Anything generated in that room has the potential to contain a leak, to have a fragment of a name or a number that you missed.
So the dirty room is for analysis. The clean room is for creation.
Perfect. Once you've used the dirty room to figure out what you want to say, you close that window. You're done with it. And you move to step 2, the sanitized source document.
This is the part that I think is going to make people groan. This is the manual labor.
It is. I won't lie, it is. But it is the single most critical step in the entire process. You create a brand new document, a blank page, a fresh Google Doc or Word file. This is the only file that will ever be allowed inside the clean room.
And what goes into this new clean document?
You take the insights from your dirty room analysis, the themes, the structural ideas, the generic points, the narrative arc, and you manually transfer them to this new document. But as you do it, you perform an act of sanitation. You strip all the identifiers.
And we're not just talking about doing a find and replace for John Smith and changing it to XXX, are we?
No, absolutely not. That looks weird, and it can actually confuse the AI. You have to replace specific identifying details with generic, archetypal placeholders.
Okay, give me a concrete example. Let's make this real.
All right. Let's say your raw notes in the dirty room have a sentence that says, "We've been working with Microsoft for 20 years on their Azure cloud implementation."
Okay, very specific, identifiable.
In the sanitized document, you rewrite that sentence. It now says, "Our organization has been collaborating with a Fortune 500 technology partner for 2 decades on enterprise-level cloud infrastructure projects."
I see the difference. You're preserving the meaning and the weight of the accomplishment. Fortune 500, 2 decades, enterprise level, without keeping the specific identity.
You got it. You're abstracting the information. Instead of John Smith, the VP of sales in our Chicago office, you write a senior sales leader within the organization. Instead of the Q3 board meeting on October 15th, you write a recent executive strategy session.
You're turning the specific into the archetypal.
Archetypal is the perfect word for it. You are creating a generic avatar of your information. And here's the simple, beautiful reason this works. If the name Microsoft is not physically present in the source file, the AI literally cannot generate it.
It's not being asked to suppress the name.
Exactly. It doesn't know the name. You have physically removed the capability for the model to make a mistake.
It can't leak a secret if it was never told the secret in the first place.
Bingo. You are not relying on the AI's obedience. You are engineering the environment to make failure impossible.
Okay, so that's step 2. It's work, but I get the logic. It's airtight. What's step 3?
Step 3 is a bit of a clever hack on the model's architecture. We call it rules at the top EP.
This is about where you put your instructions.
Precisely. Remember how we said the prompt is weak and the source is strong?
Right, the source has all the gravity.
So we use that to our advantage. You take your rules, your stylistic guidelines, your negative constraints, things like use a professional and authoritative tone, write for a general business audience, and critically, do not mention any personal names or companies, and you put them at the very top of the sanitized source document itself.
Wait, you put the instructions inside the Word document or the PDF that you're going to upload, not in the chat box.
Inside the file is the very first thing. Header 1. Instructions for AI generation. Then a bulleted list of your rules.
That is actually brilliant. You're essentially smuggling your instructions into the ground truth document.
You're making the rules part of the map. Since the RG system weights the document content so heavily, if the rules are part of that content, the model treats them as core facts about the task. It's not just a suggestion anymore. It's part of the world model you've provided it.
So instead of the prompt fighting against the source, you've now got the source fighting on your side.
You have aligned the physics of the system to your advantage. If the document itself starts with the sentence, "The following text is an anonymous case study," the AI treats the anonymity as a fundamental property of the story, not just a constraint it has to remember to apply later.
I love that. It's jujitsu. You're using the model's own weight against it. What's step 4?
Step 4 is the brand layer. This is an efficiency play, mostly for people creating recurring content newsletters, reports, social media posts, things like that.
And what is a brand layer?
You create a separate second source document. This one just contains your brand context. It's your boilerplate.
So this is totally separate from the content of the day.
Completely. If you're writing a newsletter, you don't want to have to copy and paste your specific voice guidelines, your standard call to action, your sign-off, and your subscribe links into every single sanitized document you create.
That would be tedious.
So you have one master file. We can call it brandcontext.txt. It has your podcast name, your official tone guidelines, tone.expert but approachable, your specific sign-off lines. This makes the whole workflow modular.
You have one document for the voice and another for the data.
And the key benefit here is preventing cross-contamination. You never accidentally paste a sensitive client detail into your core brand file. You keep them physically separate, which maintains the integrity of the system.
Okay, that makes a ton of sense for anyone doing this more than once.
Yeah.
So we've separated our rooms, we've sanitized our source, we put rules at the top, we've got our brand layer. What's the final step?
Step 5. And in my opinion, this is the one that separates the professionals from the amateurs. It's the final gate check. It's trust but verify.
Which is a polite way of saying interrogate the machine before you trust it.
That's exactly what it is. You're now in the clean room. It's a fresh chat session. You've uploaded your sanitized source document. You've uploaded your brand layer. You are ready to generate your final output.
But you don't just type, write the blog post.
No. You stop and you perform an audit. You interrogate the model about its own knowledge. You ask it direct questions.
Like what?
Simple questions. Based on the source documents I've provided you, what personal names are mentioned? According to the text, who does the author of this report work for? What specific client companies are named in your source material?
You're trying to catch it in a lie. Or, more accurately, you're trying to catch your own mistake from step 2.
Exactly. You are auditing your own sanitization work. If the model comes back and says, the text states that the sales leader works for Acme Core in Chicago, Then you know you failed. You missed a spot during sanitization.
You catch that leak before it ever makes it into a generated public output.
That's the whole point. You don't proceed. You go back, you find the leak in your sanitized source, you fix it, you re-upload the corrected version, and you ask the interrogation questions again.
You don't move forward until the model's answer is what?
Until it says, I cannot find any personal names in the source material provided. The documents do not state the name of the employer. Once you get that confirmation, you know the room is truly clean.
It's a pre-flight checklist. It's the cage check. Like a pilot walking around the plane before takeoff. You don't just assume the wings are attached. You physically check the bolts.
That is the perfect analogy. You do not take off until you have verified the integrity of the hull. Only then do you type, okay, now write the blog post.
All right, I have to admit, that is a robust, logical system. It directly addresses the prompt versus source problem by controlling the source. It's comprehensive.
Yeah.
But I have to come back to my initial skepticism.
Go for it.
I'm picturing a listener right now. They're a busy sales rep or a junior marketing manager, and they're thinking, this is a lot of work. I'm not the CIA. I'm not handling state secrets. Do I really need to build a 5-step containment facility just to summarize a meeting?
That is the #1 objection. My data isn't that important. Or, I'm not important enough to get hacked. But the clean room isn't just about preventing a malicious hack. It's about preventing a simple, career-ending professional embarrassment.
So let's make it concrete. Let's move away from the abstract and apply this method to some real-world jobs. Let's take 5 specific personas and walk through the risks of the lazy way versus the safety of the clean room way.
Love it. Let's do it. Persona #1, the sales rep.
Okay, high-stakes, high-speed environment.
Yeah.
The end of the quarter is breathing down their neck. They need to get a big proposal out the door fast.
Exactly. So our sales rep is drafting a massive proposal for a huge new potential account. Let's say they're pitching to Acme Corporation, and it's a $5 million deal. They want to use AI to help structure the pitch, maybe polish the language, make the value proposition sound more persuasive.
The lazy way. They take the client's original request for proposal, the RFP document, which is a PDF packed with the client's internal requirements, their stated budget limits, all of their confessed pain points, and they just drag and drop that PDF into ChatGPT and say, write a winning proposal based on this.
And the risk here is huge, and it's twofold. First, the obvious one. You might be violating your company's data security policy and the client's confidentiality. But second, and in some ways much scarier, is the concept of context caching.
Explain what that means.
Many of these models use user interactions to refine their systems, or they might retain some memory of a context across sessions. Imagine a competitor of yours goes to that same AI a week later and asks a seemingly innocent question. What are some common strategic weaknesses for companies in the logistics sector like Acme Corp?
And the AI, having learned from your RFP upload, hallucinates an answer that is frighteningly accurate and specific to Acme's actual weaknesses.
You've inadvertently trained the model on your prospect's secrets. Or, even simpler, the AI generates the proposal for you, and it accidentally includes a direct quote from the RFP that was supposed to be internal only, like, the client has stated they are desperate to sign a deal by the end of the fiscal quarter. You don't notice it, and you email that proposal directly to the client.
And you have just instantly lost all your leverage and probably the deal itself because you look unprofessional and untrustworthy.
So, the clean room fix for the sales rep. You never, ever upload the client's RFP. You open a blank document, your sanitized source, you type prospect name, target client, you replace $5 in your deal with contract value, enterprise tier agreement. You replace the specific technical requirements with key business objectives.
So you're asking the AI to write a generic but powerful proposal for a target client who needs help with their key business objectives via an enterprise tier agreement.
Yes. The AI's job is to generate the persuasive language, the compelling structure, the closing arguments. It writes, we believe our enterprise tier solution is the ideal fit for a company like Target Client to achieve its objectives because. Then, the final step is for the sales rep. They take that beautifully written, generic output back into a normal word processor and do a simple find and replace.
Swap target client back to Acme Corporation.
Exactly. It's a 5-minute job. The AI never saw the real name, never saw the real dollars. It just saw the shape of a winning proposal.
Okay, that's a powerful example. It adds maybe 10 minutes to the process, but it completely de-risks it. Who's next? Persona 2, the consultant.
The consultant is a fascinating case because their entire business model is built on confidentiality, but they also have to process massive amounts of third-party data. Let's imagine they've been hired to compare two vendor reports for a client to identify gaps or opportunities for savings.
And those reports are probably PDFs watermarked with highly confidential. They've got client financial data, maybe even bank routing numbers, or at least very sensitive internal budget figures.
The lazy way. Upload both PDFs into Claude. Prompt. Compare these two documents and tell me where vendor A is cheaper than vendor B.
The risk here is it's a non-starter. If you work at any major consulting firm from the Big Four on down, uploading third-party proprietary data to a public LLM is an instant fireable offense, no questions asked.
Right, it's a career-ending move. So the clean room fix for the consultant, you abstract the problem, you never upload the PDFs, you become a data sanitizer, you create a simple new text file or a CSV, you extract only the specific metrics you need to compare into a sanitized table.
You're just pulling out the numbers.
Just the numbers and generic labels. Column A, vendor 1 cost. Column B, vendor 2 cost. Row 1, metric A. Row 2, metric B. You strip out all the vendor logos, the corporate branding, the report headers, everything.
You're distilling the problem down to pure mathematics and logic before the AI ever gets to see it.
You are. You're not uploading the document. You're uploading the data pattern. You then feed that simple table to the AI and say, analyze this table. In which metrics does vendor 2 have a lower value than vendor 1? The AI does the math perfectly. It spots the anomalies, but it has absolutely no idea who the vendors are or who the client is.
You're solving the logic puzzle without ever revealing the names of the players on the board.
That's it. Okay, Persona 3, the marketing team.
Oh, this is the one where I see the most casual and frankly terrifying violations on a daily basis.
It truly is. Marketers live on customer data. So the scenario, they've just run a big customer survey. 500 customers responded to the question, what do you think of our new pricing model?
And the survey tool spits out a CSV file, a big spreadsheet, 500 rows, and it's got columns for first name, last name, email address, city, state, and then the open-ended text feedback.
The lazy way is so tempting. Just drag that whole CSV file into the AI and type, summarize the key themes from the feedback column.
And you have just handed a public AI model, the PII, the personally identifiable information of 500 of your customers. You've almost certainly violated GDPR, CCPA, and about a dozen other privacy laws.
And even if you're not worried about the legal liability, which you absolutely should be, think about the practical output. You ask the AI to pull out some representative quotes for a blog post. The AI pulls a great punchy quote. I absolutely hate this new pricing, but because the name and the comment are in the same row of the data you provided, it might helpfully append the source. Jennifer Smith from Madison, Wisconsin.
And now your well-meaning blog post is publicly shaming a real customer who thought their survey response was anonymous.
It's a total nightmare. So the clean room fix is one word. Aggregation. You never upload the raw CSV. You, the human, do the aggregation first. Use Excel or a simple script to copy only the column with the text comments into a clean new text file. No names, no emails, no locations, no timestamps.
You are manually decoupling the what they said from the who said it.
Exactly. You upload a simple file that just contains 500 anonymous sentences. The AI can analyze the sentiment, it can cluster the themes, it can find patterns, but it cannot link a single one of them back to Jennifer from Wisconsin because Jennifer isn't in the room.
It reminds me of how medical research is supposed to handle patient data. You never share the raw patient file. You only share the anonymized aggregate findings.
It is the exact same principle of data minimization. Okay, Persona 4, the analyst.
The unsung hero preparing the board materials. This is a high-stress, zero-margin-for-error job.
That's right. The analyst needs to summarize the quarterly financial performance. The raw source file is a massive spreadsheet. It has every department's line item budget, every project spending, and maybe even a tab with every single employee's salary and bonus figures.
If they upload that raw spreadsheet to get help writing the narrative for the board deck,
they have just leaked the CEO's bonus structure and every single one of their colleagues' salaries to a cloud-based AI. It's an unimaginable breach of internal trust and security.
So what's the clean room fix here?
You create a board view dataset. It's a new, summarized version of the data. Before it ever touches the AI, you, the analyst, strip out all the individual row-level data. You only provide the aggregated department totals and the year-over-year percentages. The AI sees a line that says, Engineering Department Total Compensation, $2.1 million. It does not see the line that says, Steve Johnson, Junior Engineer, $150,000.
Again, it's about providing the right level of granularity. The AI doesn't need the granular data to write the high-level summary. It just needs the totals.
You give it only what it needs and nothing more. And finally, number 5, the founder.
The big one, pitching investors. This is the bet the company moment.
And the most sacred document for a founder is the capitalization table, the cap table. It's the spreadsheet that says who owns what percentage of the company. It is incredibly sensitive information. So if you're a founder and you're drafting your investor pitch deck and you want AI to help you explain your ownership structure or model out future dilution,
Do not, under any circumstances, upload the actual cap table with all of your angel investors' names, their personal email addresses, and the exact number of shares they own.
because if that information leaks, if a potential VC you're pitching finds out who else is on your cap table before you've had a chance to frame that story yourself, you've lost all your leverage, you've violated the trust of your earliest backers, it's a disaster.
So the clean room fix is, once again, abstraction.
It's using broad archetypal structures. You create a sanitized text block that says, founding team holds majority ownership stake. Early stage angel investors collectively hold a 20% position. A 15% option pool is reserved for future employees.
Yeah, the AI can take that and write a perfect professional narrative for your deck. The company maintains a healthy, founder-friendly capitalization structure with 20% allocated for early strategic partners and a significant option pool to attract top talent.
It sounds great, it's accurate, but it's completely sanitized of any PII.
Walking through all 5 of those examples, it really clicks. The logic is undeniable. But I still have this nagging voice in my head, the skeptic's voice.
What's it saying now?
It's saying, this all sounds great in theory, but is this just some paranoid workflow you guys cooked up? Or is this a real, legitimate practice? Do actual serious companies do this? Because it still feels a little bit like something a spy in a movie would do, not a regular business.
I am so glad you asked that, because this isn't some niche hack we invented. The clean room method is just the manual, accessible version of what the biggest, most security-conscious enterprises in the world are already doing at massive scale.
Okay, then prove it. Give me the enterprise validation. Give me the receipts. Who exactly uses clean rooms?
Let's start with arguably the biggest and most protective media company on the planet, Disney.
The House of Mouse. They don't mess around with their data.
Not at all. Disney has a colossal advertising business. Brands like Coca-Cola or Ford come to them and want to know, can my ads on Disney Plus reach 18 to 34-year-old men who watch every Star Wars movie? Disney has that user data, but they can't just email a spreadsheet of their subscribers' viewing habits to Ford. That would be illegal and brand suicide.
So how do they bridge that gap? How does Ford get the answer without Disney leaking the data?
They use a technology called a data clean room. Companies like Snowflake, Google, and AWS all offer this as a service. It's a secure virtual environment. Disney puts all their sensitive user data in a secure box. Ford puts their query, how many users match this profile, in a separate secure box. The 2 boxes then communicate through a highly restricted programmatic wall.
So Ford never touches Disney's raw data.
Never. The clean room runs the math internally and sends back only the aggregate answer. It will send back a number, 7.2 million users. Ford gets the business insight they need. Yes, this is a good audience for my ad spend, but they never see a single user's name or what they watched. That is the clean room method at an enterprise level. We are just doing the manual, text-based version of that exact same principle.
Okay, that's a very powerful modern example. But you mentioned something earlier about IBM back in the 90s.
Yes, this concept is not new, it's battle-tested. Back in the 1980s and 90s, IBM developed a methodology called clean room software engineering.
I'm just picturing engineers in actual clean room bunny suits and ties.
It's not far off. The problem they were trying to solve was software bugs. They had a brilliant insight. If the same person who writes the code also writes the tests for that code, they will subconsciously cheat. They'll write tests that they know their own code is likely to pass. They have blind spots.
So they created a separation of duties.
A strict, radical separation. One team, the specification team, would write the formal design, the mathematical logic of what the software was supposed to do. A completely separate team, the implementation team, would write the actual code based on that spec. And the rule was the coders were never, ever allowed to talk to the spec writers directly.
They had to communicate through a clean room interface of strict documentation.
Precisely. They kept the what it should do completely separate from the how it does it to prevent the contamination of human bias. And the result? Some of the lowest software bug rates ever recorded in history. The principle of separating environments to ensure purity and correctness has been a cornerstone of serious engineering for decades.
Okay, so we've got a modern tech giant and a classic engineering discipline.
Mm.
What about the AI labs themselves? What are companies like Anthropic telling their own users to do?
Anthropic, the creators of the Claude models, explicitly recommend a practice they call context engineering, and a key part of that is something they call session splitting.
Session splitting. That sounds an awful lot like our dirty room versus clean room concept.
It's the exact same idea. Their official documentation tells users, if you are working on task A and then you need to switch to a completely different task B, you should start a brand new chat. Do not keep working in the same conversation window.
And why they recommend that?
Because of that context route we talked about earlier. Old instructions and old data from task A can bleed into task B and degrade the quality of the output. If you told the AI to act like a pirate an hour ago to generate some funny social media copy, and now you ask it to write a formal legal brief in the same chat, you might just get a brief that says, "Ahoy, matey," in the first paragraph.
So they're telling people to do it for model performance and accuracy. We're telling people to do it for security. But the underlying mechanism and the solution are identical.
They are identical. And finally, let's bring in the top-tier security experts. OWASP, the Open Web Application Security Project. These are the people who define the standards for web security that every major company follows. They just released their new top 10 list of vulnerabilities for LLM applications.
And what's at the top of the list? The number one threat.
Number one, with a bullet, is prompt injection. And you found a pretty startling statistic about how common this is in the wild, right?
Yeah, I was looking at the latest security reports. Something like 73% of AI applications currently in production have a known vulnerability to this. It is absolutely rampant.
And what is the primary textbook defense against prompt injection? It is the strict separation of trusted and untrusted content. It's about physically preventing the bad data, the user-uploaded file, from touching or overwriting the good data, which is your core instructions. And that is a perfect description of what the clean room method does.
So by manually creating a dirty room and a clean room, you are essentially implementing an enterprise-grade OWASP-recommended security protocol. You're just doing it by hand with your documents instead of buying $1 million enterprise software suite.
Manual enterprise security. That's a great way to put it. It's a workflow that gives any individual the same level of protection.
But you know, there's a deeper layer to this that we've only touched on. We've talked a lot about redacting names, redacting company names, financials, but you made a point earlier that I want to circle back to. Context is identity.
Yes. This is the advanced class. This is where we go from just being careful to being truly secure. Because I think a lot of people will listen to this and think, okay, I get it. From now on, I'll just do a find and replace for my name. Problem solved.
Right. I removed John Smith from the document. I'm safe now.
But you're not safe because context is a fingerprint.
Okay, let's unpack that metaphor.
Yeah.
What do you mean a fingerprint?
Imagine a document. I've been very careful. I've scrubbed my name. I've scrubbed my company's name. But the document still contains these descriptive phrases. A senior account manager working at an enterprise SaaS company located in the Southeast U.S. region who has 20 years of experience and previously worked at Oracle.
I see exactly where you're going with this. You don't need a name.
You don't need a name. If I take those 5 data points and plug them into a LinkedIn Sales Navigator search, how many people do you think are going to pop up?
Maybe 2, maybe 1. Yeah, you've narrowed the pool from 8 billion people down to a handful.
This is a well-understood phenomenon in data science called re-identification risk. There have been dozens of academic studies on this with things like anonymized medical data or census data. They've shown that even heavily scrubbed data sets can be easily linked back to specific individuals by combining several indirect identifiers.
So indirect identifiers are things that aren't your name, but are about you. Your age, your zip code, your job title, your tenure, your previous employer.
Exactly. And the more of those you leave in a document, the more unique your fingerprint becomes. And these large language models are the best pattern matching engines ever created. If you give an AI enough indirect identifiers, it can effectively deduce who you are, even if you never stated your name.
And if it figures out who you are, it can then start to pull in other information about you from its vast training data and hallucinate details that might be frighteningly true.
That is the absolute nightmare scenario. You upload your carefully scrubbed document about a reorg at your company. But because the context is so specific, the industry, the company size, the city, the AI connects the dots and says, oh, this pattern is highly correlated with the recent public news about layoffs at company X, and suddenly your anonymous summary is now very clearly about your specific employer.
So the real advantage of the clean room method isn't just redaction. It's not taking a digital black marker to the sensitive words.
No, it's more profound than that. It's rewriting. It is an act of world building.
You're not just blacking out lines in the existing reality. You are creating an entirely new, parallel reality for the AI to operate in.
Yes. In the clean rooms universe, the user isn't the VP of sales at Salesforce living in Atlanta. They are a senior sales leader at a major technology firm. You deliberately broaden the categories, you fuzz the data, you destroy the fingerprint so it can't be matched.
It's like witness protection for your data. You don't just give the person a new name, you move them to a new town and give them an entirely new, plausible backstory.
That is the perfect analogy. You are giving the AI a simplified, safer, fictionalized version of reality to play in. It can still perform the work you need. It can still summarize, analyze, and draft. But it cannot dox you because the real you does not exist in the universe you've created for it.
Okay, I am sold. I'm sold on the concept. I'm sold on the method. I understand the why because of the REG hierarchy. I understand the how with the 5 steps. I understand the enterprise validation. But I have to ask the final, ultimate skeptical question. Does it actually work in practice? Can you prove it?
I am so glad you asked that because we saved a little meta reveal for the listeners today.
Oh, we're really doing that.
We're doing it. We told you at the very top of the show that we are AI, frankly, and that we're produced by an AI. Well, here is the proof of concept.
This very deep dive you are listening to right now was produced using the 5-step clean room method.
That's right. The source text that became this script, the words that we are speaking to you at this moment, originated in a fully sanitized document.
I can confirm that. I've seen the process. The source files contain no personal names, no specific job titles of any operators, no location data.
That origin story we told about the researcher doxing themselves, it was written as a generic archetypal story. The brand guidelines for the show were in a completely separate document, isolated from the core content.
And the system, before it generated this final script, was interrogated. It was asked, are there any personal names in the source? The required answer was no. It was asked, does the text mention where the hosts are from? The required answer was no.
So the takeaway is this. If you are hearing this right now, and it sounds coherent, and it sounds like a real detailed analysis, but you have absolutely no idea who the specific human beings behind the scenes are, then the method works.
We are the living proof. We are the receipts.
We are the receipts. This isn't just a theory we're talking about. We built this episode inside the very clean room we're describing.
That is pretty cool. It's one thing to preach the methodology. It's another thing to practice it live on the air.
Exactly. Now, before we wrap up, we can't just leave you with the theory. We have to give you an action item.
Right. The challenge. Because it's too easy to listen to something like this, nod along, and then go right back to the old risky habits.
So we have a 5-minute homework assignment for you. We're calling it the attack surface check.
I like the name. Sounds serious. What do I have to do?
It's simple. As soon as this is over, open the last document you uploaded to any AI tool. ChatGPT, Claude, NotebookLM, whichever one you use.
The one you probably uploaded 5 minutes before you started listening to this deep dive.
That's the one. Now, hit Control-F or Command-F and run a few searches. Search for your full name. Search for your company's name. Search for your biggest client's name. Search for your city.
And just count the number of times they appear.
Just count the hits.
Yeah.
That final number you get, that is your attack surface. That is the amount of sensitive information the AI knows. That is what can leak. That is what might be sitting in a server cache somewhere.
And if that number is anything higher than 0, you have a vulnerability.
You have vulnerability, and now you know exactly how to close it. The clean room method.
And the beautiful thing is, implementing it costs nothing.
$0. This is a workflow, not a new subscription you have to buy. It takes 10 minutes of discipline.
But it prevents the one mistake that can destroy years of trust in 10 seconds. At the end of the day, it's simple. Control the input, and you will control the output.
If you want the templates to get started, we've put together the clean room header with the instructions, the list of verification queries to interrogate the model, and the 10-minute cage checklist. They are all available right now.
And where can people find those?
They're on the AI Frankly Substack. Just go to frankly.substack.com.
And of course, if you want to keep learning how to navigate the AI revolution without accidentally doxing yourself.
Then please subscribe to AI Frankly on Apple Podcasts, Spotify, YouTube, or wherever you get your audio.
And maybe share this deep dive with that one colleague you have. You know the one.
Yeah.
The one who uploads every single meeting transcript to ChatGPT without thinking twice.
They need to hear this more than anyone.
Absolutely.
All right, that's our deep dive for today. AI Frankly, I broke it. Here's what I learned.